Good morning, everyone. How are you all? I hope everyone is good and we are good to go for today's session, which is alternating current. In this session, we will discuss or we will focus on question discussion. I have taken some questions. The PYQs actually I have taken previous year questions. So we will try to cover them up. So be alert, be focused. So first of all, we will wait for few minutes, 1 or 2 minutes for some persons, some students to join actually. After that, we will start. Your exams are approaching, so I hope you all are doing good. Okay. So let's start our discussion. So the first question on your screen, I will give you some time to solve the question. I will give you some, I will say 1 minute to solve this question. Around 1 minute will be enough to solve the question. And along with you, I am also reading the question. You can see this is an AC circuit containing a resistor, an inductor, and an capacitor. Let's suppose its inductance is L, capacitance is C. Clear? So this circuit has three voltmeters connected V1, V2, and V3, and the values of V1, V2, and V3 is given as V1 and V2 is equals to 40 volt, V3 is equals to 10 volt. And the frequency of source is given as 100 pi. Find the value of X if L minus C has a value of this one. So L and C, you need to calculate the value of L and C to complete the question. So you have 1 minute of time. You can take your time. Okay. I hope you have completed the question and at least read the question. Now look at me. If I put the values, this V1 is equals to 40 volt, V2 is equals to 40 volt, and V3 is equals to 10 volt. These are the values given. Now these three components are connected in series. That means current will be same throughout, and the current is I that we have taken I. So if I say current in 4 ohm resistor. Good morning, JNV Visakhapatnam. How are you? So read the question. After that, after 1 minute of time, I will start. So the question says these are the three components. I am explaining the question R, L, and C. These are the three components connected in series. Cross them, there is a voltmeter V1, V2, and V3, which gives the reading of voltage across resistor, inductor, and capacitor. The values are given 40 volt, 40 volt, and 10 volt. Clear? And the frequency of source is given as 100 pi. And you need to calculate the value of L minus C. That means you need to calculate the value of L and C both. So I am starting that current in 4 ohm resistor. If you say potential is 40 volt, resistance is 4 ohm, so I is equals to, you will say V by R. Potential is 40, resistance is 4, that means current is going to be 10 ampere. This 10 ampere current is passing through the resistor and all these components are in series. That means this current will be same throughout the system. Inductor will also have 10 ampere current. Capacitor will also have 10 ampere current. Is this point clear? Now, I need to calculate L and C. Now for inductor, if I say, the potential across inductor, if you write using Ohm's law, V is equals to I into R. Current is I and the resistance of inductor is denoted by XL. I hope you know that thing. This is known as inductive reactance. Okay. Now, what you can say, VL is equals to 40 volt, current is equals to 10 ampere, and XL, you can write it as omega L. So L can be written as, this can be cancelled 4, that is 4 by omega. Is it clear? I hope this point is clear to everyone. This is equation number 1. Now, if I write it for capacitor, if you write it for capacitor, again you will see potential applying Ohm's law, potential across capacitor is equals to current and its resistance. And the resistance of capacitor is nothing but its reactance, that is XC. Again, put the values. Potential across capacitor is given as 10 volt. Current is 10 ampere. XC is what? 1 upon omega C. I hope you know that. So from here, 10 and 10 can be cancelled and C is equals to 1 by omega. You need to calculate the value of L minus C. And if you want to calculate the value of L minus C, what it will be? So L minus C will be 4 by omega minus 1 by omega, that is 3 by omega. Now 3 by omega is what? 100 pi. So they are asking you the value of X. According to the question, they have given you a value X over 100 pi. So X is what? 3. From this, you can conclude X is equals to 3. So this is your answer. I hope this is clear to everyone. Bhagwati is saying yes. You. Okay. So X is equals to 3. This is your answer. Is this question clear to everyone? So moving forward to the next question. Okay. So the question is on your screen. You will be having some 1 minute time to solve the question. Take your time. You have some 30-40 seconds remaining to solve the question. This is the easiest question in which current is given as 2 root T, average value and RMS value they are asking from time 2 second to 4 second. So I can give you a hint actually. What is I average or average value of current can be written as integration I dt divided by integration of dt. So if you can recall it, this IDT or integration IDT was the area. If I just recall the things, this was the area and this DT was the time period. So time period you can see from the question is 2 second to 4 second. That means time period is of 2 seconds. Clear? So now you just need to put the values. So I average is equals to integration I dt. I is what? 2 root T dt divided by what is the time period? Time period is 2 to 4 seconds, that is 2 seconds. So this 2 and 2 can be cancelled. So if I move here, average value of current can be written as what is the integration of root T? I hope everybody knows the integration of root T. That is, if I use the limits 2 second to 4 second, that is T raised to the power 3 by 2, 2 by 3, from where to where? 2 to 4 seconds. Clear? Now you can just put the values, put the limits. I average is equals to 2 by 3. If I put 4 in place of t, that is root of 4 to 2 raised to the power 3, that is 8 minus 2 root 2. So this is your average value of current. I average is what? 2 by 3, 8 minus 2 root 2. 2 by 3, 8 minus 2 root 2. So this is, I think, only option A it is given. In only option A it is given. Clear? Now, what is the RMS value of current and how you calculate RMS value of current? So for that, if I say IRMS is equals to root of mean of I square. This is what we can say IRMS. Now it can also be written as IRMS is equals to root of integration I square dt divided by time period is what? Dt. Now you can put the values. If you put the values IRMS root of integration of I square, if you do it will become 4t dt from 2 to 4. And what is the time period? Time period is what? 2 seconds. So it can be 2. So IRMS, if you solve root of 2 is here. And if you integrate the t, that will be t square by 2. T square by 2, limit is from 2 to 4 seconds. This is just the calculation. That is 4, that is 16 minus 4, that is 12. So that is root of 12, that is 2 root 3. 2 root 3 is the RMS value of current. So out of this, which option is correct? Option A is correct. Clear, everyone? Okay. Which option is correct? Option A is correct. That is good. So now you know how to calculate average current and how to calculate RMS value of current. So on this note, I am giving you another question and you just need to answer the question very quickly. This is another question on your screen. I will give you some 1 minute of time to solve this question. You have 1 minute of time to solve this question. Anyone from YouTube who wants to answer? So IRMS is what? Root of mean of I square. That thing you should remember. Now, what is I? I is given as I1 sin omega t, I2 cos omega t. So you just need to square it. As per the relation, you just need to square it. So IRMS will become root is already there. This is there. And mean of I square. JNV Shimoga is there. I square, if you square this term, then it will be written as I1 square sin square omega t. Can you do it with me? Plus I2 square cos square omega t plus 2I1 I2 sin omega t cos omega t. And this is saying average of these values. Now, if you can remember from the previous classes or the basic concepts, the average value of sin square theta and cos square theta is 1 by 2. If you don't know, I am writing it here. Average value of sine square theta and average value of cos square theta is 1 by 2. Clear? And average value of sine theta, or you can say average value of sine 2 theta, similarly average value of cos 2 theta, all these values are 0. So what I'm saying, average value of sine square theta is what? 1 by 2. And average value of sine theta is what? 0. So from this question, if you look closely, this is the average value of this total three terms. So out of this, sine square omega t will have an average value. You will say root is already there. That is I1 square is a constant. Sine square omega t will have an average value of 1 by 2. That is 1 by 2. Plus I2 square is a constant. Cos square omega t has a average value of 1 by 2. Plus I1 and I2 is there. And 2 sine omega t cos omega t is sine 2 omega t. And sine 2 theta has a value of average value is 0. 0. So what is the final RMS value? You will say final RMS value is what? This 2 can be taken out, that is 1 by root 2 root of I1 square plus I2 square. So this is your answer, which is correct option number A or B. Which is the correct option? That is correct option number B. So I hope, sorry, by solving these two questions of average and RMS value, you know how to calculate RMS value. Now moving towards the next question. Read the question carefully. I will give you some 1.5 minutes or 1.5 minutes to solve the question. Take your time because language is little bit lengthier on the lengthier side, but the question is easy. All these questions were asked in previous year questions. GNV Shimoga is there. Can you get the answer? Shimoga is in which state of India? Shimoga is in which state? Like it's in Andhra or Telangana or where it is? It sounds like in Punjab. Anyway, waiting for your responses. Anyone getting the answer? Question is very simple. Just try to read the question first of all, what it says, and thinks there is a coil, a capacitor, and an AC source of some RMS value 24 volt are connected in series. Okay. By varying the frequency of the source, a maximum RMS current 6 ampere is observed. Now you are changing the source frequency and a maximum RMS current of 6 ampere is observed. So now look at that. First, read the question again. If this coil is connected to a battery of EMF 12 volt, now they are connecting it with the DC and internal resistance 4 ohm. Then calculate the current through the coil. Okay. So we need to draw two diagrams. First of all, there is a coil. There is a coil. Coil is, you know, that inductor type of system. There is a coil. If there is a coil and it is not mentioned that coil is resistanceless, then this coil will certainly have some resistance. Are you getting my point? It is not mentioned in the question that it is resistanceless. If you are coiling a wire, if you are making a coil of a conducting wire, then this wire will have some resistance. So this resistance, I am saying, let's suppose this resistance is R, this inductance is L, and a capacitor. All these things are connected with an AC source. This is the AC source, which has some RMS voltage 24 volt. So this has some RMS voltage 24 volts connected in series. Now maximum current. Now look at that. This is series LCR circuit. And in series LCR circuit, when maximum current is observed, can you answer this point? In series LCR circuit, when maximum current is observed, you will say, sir, maximum current is observed when the circuit is in resonance. And in resonance, the effective resistance or the impedance of the circuit is just equal to the resistance. So what I'm saying, I is equals to, you know the formula, E over Z. And you are saying RMS. So I will say RMS EMF will be used. No problem with that. Now, if you talk further, IRMS is given as Y watt, is given as 6 ampere is equals to ERMS is given as what? 24 volt divided by Z. Z is the impedance of the LCR circuit, but for maximum current, it should be in resonance, and in resonance, impedance of the LCR circuit is what? Can anyone answer? What is the impedance of the circuit in resonance condition? That is equals to, yes, that is equals to resistance. So you can calculate the resistance, and R is coming out to be 4 ohm. Clear. Now in the second part of the question, they are saying if this coil is connected to a battery, now they are connecting only the coil, not the capacitor. They are connecting only the coil with a battery. Now just redraw the diagram. They are connecting the coil. Now coil has some resistance with a battery of EMF what? Of EMF 12 volt and some internal resistance that is 4 ohm. 12 volt 4 ohm. Now this coil has the resistance R, and that we have calculated to be 4 ohm. The resistance of the coil that we have taken, it has a resistance of 4 ohm, and this has some resistance XL. You know that. Now you need to calculate the current again. Now for the DC circuit, you know that XL is equals to omega L, and that is going to be 0. Why 0? Because omega, the frequency for DC is 0. That means XL will not raise the flow of current. Is this point clear? So for DC part, I will write current is equals to EMF over R equivalent. EMF of the battery is 12 volt. What is the total resistance of the circuit? You will say XL has no resistance. This is 4 ohm. This is 4 ohm. Both are connected. This is internal resistance. Both are connected in series. That is 8. So that is 12 by 8. And if you can simplify it, that is very easy. 4 3s are 12, 4 2s are 8. So I is equals to 1.5 ampere. Is the question clear? 1.5 ampere, which is correct option number B. So what you can learn, what you can take away from this question, that the things, first of all, try to draw the diagram. The visualization of the diagram will give you an idea that what's happening here in the question. And make sure if resistance is not given, it is not mentioned, a coil is not mentioned as resistanceless, then it must have some resistance. Moving further. Next question. In this question, date was mentioned, but it is not like that. All these questions were not asked in the previous year exams. Okay, so you again have what time? Uh, 1 minute of time to solve the question. Are you solving the question? Say at least yes or no, so that I can start quickly. If you are not solving, if you are not able to solve, if you are not able to pick what the question is asking, demanding, then you can say directly, I will start right away. And if you are solving, you need some more time, you can also demand the same. Like, sir, we need some 30 more seconds to solve the question. And YouTube family is very quiet actually. They are not saying a single word. They are online, they are watching, but they are not saying a single word. You can also comment like, yes, we can solve this question, give us some more time, some 30 seconds more will be good. Energy is not there with you guys. If you can answer, then there will be some energy in the class. Try to bring some energy out of you. Don't just waste the energies while playing. You can also utilize this energy in the question solving. Do whatever, give us the wrong answer, but at least try to be involved. Shimoga and Vishakhapatnam. Okay. So I hope you have attempted the question. There is a circuit connected to an AC source. Source has some EMF E naught sine 100t. Okay. T is in second. Okay, no problem with that. Gives a phase difference of pi by 4 between the EMF and current. Now they are saying there is an AC circuit. AC circuit is giving some phase difference of 45 degree between current and EMF, but they are not saying who is leading. They are not saying who is leading. Then, if you look at the options, there are two options. One is containing RC circuit and one is containing RL. So only RC and RL, two types of circuit are there. And both possibilities are possible. Are you getting my point? Why both possibilities? If they have given that current is leading, then you can recognize that if current is leading, then it should be RC circuit. If they have given that potential or EMF is leading by 45 degree, then you can conclude that the circuit is going to be RL circuit. But here nothing is mentioned, so you need to check for both RC and RL. Is this point clear? So what is the phase difference for RC and RL? If you can remember, if you can remember, I hope everyone can remember, we were running on this chapter from the few days. So for RL circuit, you should remember what is tan phi. Tan phi is what? XL over R. I hope you remember. Tan phi is what? XL over R, where XL is what? Omega L. Omega L over R. Is it clear? Now for RC circuit, if I say here for RC circuit, what is tan phi? Tan phi is equals to XC over R, or XC is what? 1 over omega C into R. So now we know tan phi is this one. So for phase difference to be pi by 4, that is phi should be pi by 4 and tan phi should be 1, because tan 45 is 1. So what you will do, you will put these values of R and C, R and L in the respective circuits, and omega is what? 100. Omega is what? 100. And after putting the values, you need to check in which situation this is coming out to be 1, or tan phi is coming out to be 1. That's the way you can do. Okay. So we are starting with option A. So if I start with option A is for RC circuit. So we can't start here. Option A is for RC circuit. It has R and C. Put the values. So tan phi is what? 1 over omega is what? 100. C is what? 1 microfarad. 1 microfarad means 10 to the power minus 6 into R is given as 1 kilo ohm. That is 10 to the power 3. So can you see that this is 3, this is 2, 5. So minus 1 power is remaining. So that is coming out to be 10. So tan phi is 10. That is not our answer. Tan phi should be 1. And for RC circuit, we can just finish RC circuit right now, because we have started with RC circuit. So you can finish it. So in which part RC circuit is there? That is in option C. So for option C, if you check, tan phi is equals to 1 over omega CR. Omega is what? 100. C is what? 10 microfarad. That is 10 into 10 raised to the power minus 6. And R is what? 1 kilo ohm. That is 10 to the power 3. If you can see 3 to 5 and 1, 6. 6 positive, 6 negative, it is cancelled. So that is coming out to be 1. So if tan phi is coming out to be 1, that means this is our answer. This is our answer. So this is my answer. Why? Option C is my answer, because at option C, we are getting tan phi is equals to 1, that is phi is equals to 45. Is it clear? The simple question asked in 2019 in the mains examination. So I hope you can uh, gain some confidence by doing these questions. Moving further for the next question. Now the question is of transformer. This is the easiest question out of all. You have some 1 minute of time to solve. Now, if you look at the question, the efficiency of the transformer is not given. It means that transformer is fully efficient and there is no loss. You know that losses in the transformer, the flux loss, the hysteresis loss. I hope you remember all these things. So there is no loss in the transformer. The efficiency is going to be 100%. Clear? So if efficiency is going to be 100%, look at that. A transformer consisting of 300 turns in the primary. So according to the question, N1 is given as 300 and 150 turns in the secondary. That means N2 is given as 150. So which kind of transformer it is? Can you conclude it from here? Which kind of transformer it is? It is step down or is it step up transformer? Can you conclude it in your mind? Like after seeing the number of turns in primary and secondary, you should conclude that this is going to be step down transformer. Clear? Gives output power of 2.2 kilowatt. Output power. That means P output is given as 2.2 kilowatt. Okay. If the current in the secondary, now again I2 is given as 10 ampere, then the input voltage they are asking. So first of all, we will start like a golden relation. That golden relation is V input over V output is equals to N1 over N2. I hope you remember this golden relation. Clear? So for V input, for the calculation of V input, you will do N1 over N2 into V out. So what is your primary focus? Your primary focus is now to calculate V out. Like, just don't look at the question, look at the approach. Most of the students suffers one thing, like, sir, where I need to start, from where I should start. So there is no problem. They are asking the input voltage with you. So look at the transformer and find a relation which involves input voltage. So I know a relation that input voltage over output voltage is this one. And out of this N1 and N2 are known, only V out is not known. So now question will definitely have something to calculate V output. Now look at the question, look at the data again. What is that part which by using that part you can calculate V output. So if I look closely, I have output power. And you know that power is what? V into I. So you can say that P output is equals to V output into current in the secondary is what? I. Clear? So V out you can calculate. P out is what? 2.2 into 10 to the power 3 is equals to V out divided by this I2. I2 is what? 10. So if you can simplify it, 0 and it will be 2 power will be remaining. So V out is coming out to be 220 volt. Now put this V out in this question, in this equation 1. And if you put this V out, so V input is coming out to be N1 is what? 300. N2 is what? 150. V out is what? 220. That is 2. So input voltage is coming out to be 440 volt. So can you feel that? That input voltage was 440 volt and output voltage was what? 220 volt. So you can imagine that this was the step down transformer. What was that? Lag gaye 440 volt. So that was 440 volt. Is it clear to everyone? Moving further with the next question. So this is the next question on your screen. You have again 1 minute of time. If you look closely, the question is saying the magnitude of change in flux through the coil. Magnitude of change in flux through the coil. Can you see that this question is something from, I will say, EMI part, because change in flux was calculated in that part only. So just don't look at the options or the, I will say not options, I will say the formulas in AC chapter. This question belongs to what? EMI chapter. So this question is here to check the previous knowledge of your. So I hope you can solve the question. So there is a coil of resistance. Okay, I am giving you 1 minute time. Coil of resistance 100 ohm. Okay. A current is induced by changing the magnetic flux through it as shown in the figure. Current is like this. Current versus time graph is this. The magnitude of change in flux. Okay. Should I start? Look, they are asking the change in flux. Clear? So change in flux, you can recall the Faraday's law. What was that? E is equals to d phi over dt. I hope you remember. Everyone remembers E is equals to d. Negative sign I'm not using. That was used for the polarity of the EMF, which we can, which is not necessary in this question. So E is equals to d phi over dt. This d phi we need to calculate. Now E is what? EMF is what? Resistance is given. So EMF can be written as I into R. That is I into R is equals to d phi over dt. Resistance is given as something 100 ohm. So you can say 100 I, and if I can transfer dt here is equals to d phi. Clear? Now, if you integrate this thing, this is the change in flux or the small change in flux. If you change complete change in flux, you want to calculate, you just need to integrate it. 100 is a constant, it can be taken out. So this d phi integration d phi will become change in flux delta phi is equals to 100 is already there. And this I dt is what? I dt is what? Area under the IT curve. This I dt is what? Area under the I dt curve or IT curve. And this area is this one. Can you get this area? So this I dt part is nothing but the area. You can easily calculate this area. Area of the triangle is half base into height. Base is what? 0.5. 0.5 can be written as 1 by 2 into height is what? 10. Clear? So delta phi is what? You can simplify this. This 2 and 2, 4. 4 can cancel out by 25. That is 250 Weber. This is your change in flux. Are you getting my point? Can you solve it like that? What I did, they want us to calculate change in flux, and for change in flux, we need to recall one formula, that is EMF is equals to d phi over dt. No other formula you know. Put the values. E is equals to IR, IDT is what? Area, and you will get 250. 250 is what? Option number B. Clear? So this is going to be the last question that we are solving. You can take 1 minute of time again to solve this question. Okay, tell me, are you getting any of the questions? Are you able to understand what I'm saying? Or if you face any problem, you can ask me. Sir, we are facing this much of problem, this kind of problem we are facing. Say at least a single word. Or is it like what I feel like you just opened the video and just uh, doing your other work? What kind of things are happening? I can't understand. Like you played the video, opened the video, and just lying in your bed. What kind of things happening there? I can't understand. ऐसे नहीं पढ़ सकते हो आप. You need to be alert while in the class. Okay. So question says, in an AC circuit, the instantaneous EMF and current are given by. So EMF is given by 100 sine 30t. Current is given by 20 sine 30t minus pi by 4. And now as you see the equations of current, you can clearly judge that current is pi by 4 degree behind the EMF in phase. Clear? In one cycle of AC, the average power consumed by the circuit and the wattless current are respectively. Now coming. Very simple. You can clearly see that phi is going to be pi by 4. Pi by 4. What is phi? Phi is the phase difference between the two. And who is lagging? Current is lagging by pi by 4. So if you can draw, if this is my EMF, then my current will be somewhere here. This is going to be my current. And this value is what? Pi by 4. Clear? Current is lagging by pi by 4. Clear? Now, what is average power consumed? So for average power, you should know the relation. P average is what? ERMS, IRMS into cos phi. I hope you remember this relation. Now you can put the values. ERMS, maximum value of EMF is 100. And if you don't know, I can write it here. ERMS is E naught by root 2. Similarly, IRMS is I naught by root 2. So E naught is what? 100 by root 2 into IRMS is I naught, that is 20 by root 2 into cos phi. Cos phi is 45. Cos phi and cos 45 means 1 by root 2. Clear? Now, this is very simple calculation. This root 2 and root 2 will make 2, and 2 tens are 20. So this is going to be 1000 by root 2. So P average is coming out to be 1000 by root 2, which is clearly option number C. There is no other option containing this much value. So actually, our question in the examination is done now. We can clearly kick the option C and go away. But for the learning perspective, if I say you should learn one more concept here. Now look at the formula. They are asking the what less component. Now I will give you an idea. Look at me. This EMF and current and cos phi. Now, if you remember, we have dealt with this EMF and current as a phasor or as a vector, you can say. You know that part now. So look at that. If this is our ERMS vector, I am just concluding the things, and this is our IRMS vector. IRMS vector. This is our phase difference phi. So if you look at the power, power is ERMS, IRMS, cos phi. And these two quantities we have considered as vectors, as phasors, you can see. So do you have a feeling? Do you have a feeling that this P average can also be written as ERMS dot IRMS in the vector form? Is it clear? Is it clear to you that if we are assuming them to be vectors, phasors are what? We are dealing with them as vectors. So if they are vectors, then this P average can also be written as ERMS, IRMS with the dot product. And if you remove the dot product, it will be again the same result. So this power wattless component is what? The If you look at very closely, this IRMS will have two components. Can you resolve it in two components? One component will be this one, and one component will be this one. This is going to be IRMS cos phi, and this is going to be IRMS sin phi. Are you able to see what I am trying to say? This is going to be IRMS sin phi. Now look closely. This IRMS sin phi component, if you do the dot product of ERMS with this component, you will get zero power. This component is actually perpendicular to the EMF, so it will not contribute in the power. Again, I am repeating my word. This IRMS sin phi component is perpendicular to the EMF. That means angle between EMF and current is going to be 90. So this component will not contribute in power. And this component is known as wattless component of current. So what you can remember after this much of conclusion or discussion, wattless component of current is the component which is perpendicular to the EMF, is the component of current which is perpendicular to the EMF. Can you note down this line as a punchline? And if you can note down this line as a punchline, then the calculation is very simple. If I say wattless component, or I will denote it by any symbol, I wattless, you can make any symbol out of your mind, you can draw. So that is going to be IRMS sin phi. This is perpendicular component, that is IRMS sin phi. Now it is your task to put the values. IRMS is what? I naught by root 2. That is 20 by root 2. You know that IRMS is 20 by root 2. Into sin phi is 1 by root 2. This root 2 will form 220, that is 10 ampere. I hope this question is also clear to everyone. If this question is clear, on this note, I am ending the session. and see you again. There might be the exams. You might have exams from tomorrow. I hope the news is correct and you have exams from tomorrow. So all the best for your exams. Bye, everyone.